On behalf of Apache Solutions, I would like to welcome you to our today's webinar, Apache Kafka. My name is Mikhail. I am the Director of Curriculum Architecture at Apache Solutions, a consulting and training company based in Toronto. We provide a broad spectrum of regular and customized training classes in programming, system administration, and architecture to our clients for over 15 years. So today's topic is Apache Kafka. We've got 1 hour. I would like to make it as informative as possible. I cannot guarantee that I would be able to answer all of your very deep technical questions. I'll try to maybe do my best, but I would like to see as many questions as possible. Please use the questions pane, just detach it, put your question in. I will read it for the benefit of other attendees. More people I see are joining us. If not, wait until the end of my presentation. We will have a Q&A at the end. Okay, so that's it pretty much. In today's talk, we will cover the architecture of Apache Kafka, use cases, message delivery guarantees, a little bit on terminology. We will also talk about some of the distribution options that you have. I will also dive a little bit on some of the technical sides, the internals of Kafka. Not so much kind of across the board, but maybe some of the insights that might help you to maybe kind of properly assess that system. It might be that you are evaluating Apache Kafka for your future projects. So maybe you are planning to replace your existing systems. So I'll give you a little bit of various opinions that I've kind of picked up on the internet. I always take anything with a grain of salt. I don't kind of believe in hype and the kind of a propaganda when people just really have a big mouthpiece and they kind of start broadcasting and trying to induce you to make a decision. Certain technologies might require kind of a better and harder look, longer evaluation. Okay, so that's is by way of introduction. Again, I see more people coming on board. I welcome your questions. Put your questions in the questions pane. I'll read it, and I'll try to take your question. Again, as I said, if you have a very technical question, I might not be able to help you with, but anyways, I'll give it my best. We will also have a Q&A session at the end of this presentation. Okay, so let's get started. Kafka is, as probably many of you know, it's a very popular system now, positioned to replace some of the existing systems that you might have, like JMS-based systems, maybe MSMQ, WebSphere and Q systems, or similar, AMQP, and what's not. But so let's take a look at what actually it claims to be. It's a distributed, it runs on a cluster of machines. It's massively scalable, meaning that you can add machines, you can add brokers to parallelize the processing. It's a fault-tolerant message queue, which operates on the pub/sub programming paradigm. Handles real-time large data feeds. It boasts and it proves to be true on near network processing speeds, meaning your data can be processed as the data arrives on the queue. It's a JVM-based machine written in combination of Scala and Java. Runs on Windows and Unix platforms. You would definitely benefit from running Kafka and many other systems on Linux machines because some of the efficiencies that they've been able to achieve only specific for Linux, for Linux kernel. There will be one slide talking about this. Windows probably has a similar capability. I'm not aware. Documentation is not very clear, and the information that I have doesn't really shed enough light on that. Originally, it was developed at LinkedIn, then donated to Apache Software Foundation, and some of the key Kafka engineers left the company some time back, and they formed a startup which eventually became Confluent. They have this focus on promoting Kafka, commercializing, trying to monetize their expertise. They offer a community edition, and they also give you a way to have some proprietary extensions, enterprise-grade services based on subscription. So there is a question if the presentation slide will be shared. You know what? It's a common question. Usually we send that link ahead of time, and I understand some people might not be able to sit until the end of my presentation. So let me just quickly check. I'll go offline for a second. I'll send this link through the chat window. Give me a second. Okay, I posted that link in the chat window. It's the PDF slide deck. Please download it and let me know if you have any issues. Okay, so let's move on. If you really kind of take a very close look at what Kafka is, it's nothing more than just a file. It's a file, and that file has the properties of a transaction log file. Any database has this kind of a journal, the transaction log, which keeps track of all the operations, requests submitted against a database, and if database cannot, it's kind of a write-ahead log. If the database goes offline and then goes back up again, that transaction log can be played back, and those uncommitted transactions can be repeated, right? So it's a way for the system to ensure consistency and durability. So that's what it is, and the common, I guess, theme is to look at some of the existing parts, components of enterprise systems, extract them and wrap them up as a product that is popularized. So Kafka did exactly this. So that took this concept of a transaction log, and they just thought, why not make this transaction log distributed, highly available through replication, and essentially improve the kind of a consistency of your data and make your give you a messaging service which can be synchronous or asynchronous. So that's what it is in essence. They boast high throughput. All those figures, I guess they should be really reviewed closely. You need to test it in your own environment. As I said, it's distributed, it runs on a cluster. So whenever you have this cluster deployment, it's a distribution of the services. And you always have that Eric Brewer's constraint of the CAP theorem, consistency, availability, and partitioning. Same applies to Kafka, even though it's not a kind of database. It's not a NoSQL system. It's just a log-based system for passing messages. But consistency and availability are also those trade-offs that you can achieve with Kafka, even though it's positioned to be available and consistent. It supports through the connector API a number of integration points with commonly known and used systems such as Storm, HBase, Spark, and Hadoop, HDFS, Hadoop file system. So the consumer, which can pull out messages from Kafka, essentially acts as not only consumer but also as a producer, which just uses those systems listed here as sinks. Essentially just uploads the data. It does it in an efficient way, in a secure fashion, and what's not. Okay, so whenever you see those integration points, it's interestingly that Confluent, the company behind Kafka, they have contributed a great deal of connectors to relational databases, to all other systems, written in many languages. So Java, it's not the only language, it's not the only play in town. You can have Python, .NET systems, C++, and others. Messages. So that transaction log is interestingly positioned or oriented as being the asynchronous or synchronous queuing system using publish-subscribe model. And any entry, any append to that file can be treated as anything, as an event, as a message, as a record. So whenever you see in our discussion any references to those entries or additions to the log file under different names, it's just a very nice way to see what kind of use cases you might build around Kafka. So whenever you see a message, it's kind of probably gets you going on a particular kind of a messaging type of scenario. Or it can be an event-driven when you want to source, maintains the state of your communication. So Kafka supports all of those. Messages can expire. Time to live, I believe, is 7 days before it expires. It's configurable. And messages can be retained after a message has been consumed. Contrary to many existing systems, when a message has been read, it's purged by default. It can be configured to stay on the queue, but the default value is messages consumed. That's it. I need to clean to keep that depth of the queue at a minimum. Kafka has a different view. So essentially, you consume and you need to take some action to delete the message after it has been consumed. Use cases are quite varied. The original one was just clickstream, just capture page views, searches, essentially tracking user activities. That's what LinkedIn had in mind when they, I guess, financed. It's interestingly that if you look at the source code of Kafka, they still have that LinkedIn email address for many developers. Probably they just have some arrangement between Confluent and LinkedIn, kind of intellectual property arrangement. Data feeds aggregation is an interesting use case where you would capture from various sources and you would like to aggregate data and present data as if essentially kind of merge data and make it enrich your data feeds. Logs, a very popular system, logs as Apache Web Server log file, any other transactional log file. It's very good for operational purposes. So your use cases might be generally split between the business domain related and operational domain. So there is some intersect, but logs are usually just operational health, which we can help you with lots of things, monitoring distributed systems. So I guess you can, add your own use cases if you see where the whole thing is going. One of the useful use case is the buffer, which can absorb user request spikes during peak times. Since it's a file-based transaction log, you've got pretty much terabyte worth of probably sizes. Of course, it wouldn't be probably a good idea to go beyond maybe 10 gigabytes or maybe 50 gigabytes. You should keep really things under control, but at least you can absorb some unexpected rise in user activity. And then slowly you will pick up all the messages using your consumers. You can add more consumers when needed. Event sourcing, it's a very popular kind of a new term to describe that essentially you treat your messages or records as if they reflect some sort of event, kind of impressions. And it helps you to maintain the state. You can play back and reconstruct the state of a particular state machine, so to speak. And everything is ordered. We're going to talk about message guarantees in a moment. So probably just a few very popular use cases. Recently, they have started positioning themselves as a streaming system with some lightweight streaming support, but probably it's a little bit of I would say extension of what they can really do. Everything boils down to using consumers, and you probably would be better off to use maybe Apache Spark streaming, sitting behind downstream from Kafka, maybe Apache Flink. What's interesting is that they go kind of against the established enterprise messaging platforms, which are in the Java space, in JEE, Java Enterprise Edition space, based on that common API called JMS Java messaging systems. Lots of products from major place in the Java world, application servers, other platforms and messaging tools. I'm not going to name those, but they kind of build their technology around those interfaces. They have native interface, they've got JMS, and it looks like Confluent positions to maybe steal some portion of that market. I don't expect them to replace, particularly when it comes to the financial industry. Kafka is not as robust as the well-established kind of a very production-hardened systems, but they would probably get the niche, kind of steal some of the segments, kind of a revenue stream from certain use cases where they're not maybe mission critical, even though you can have really high consistency of Kafka messaging with certain configuration, with some proprietary extensions. But just be careful in jumping on the bandwagon and trying to replace all your existing systems. It's just a system which would probably need to evolve over some time, maybe 1, 2, 3 more years to have them a more established system. Right. So I mentioned integration points. I guess you can use other systems for data ingestion, other buffering solutions and data transfer mechanisms, but Kafka has proven to be a reliable system in many production deployments. Of course, it would probably require a little bit of digging on how to best configure what should be the number of topics and all other configuration aspects that we are going to talk right now. So in terms of terminologies, the things that you have to be aware when we start dealing with describing Kafka. Before I start doing that, I've got a question. I have heard Splunk is good for aggregation of such data too. Yes, it's particularly for log files. Splunk has been around for quite a few years. As far as I remember, it probably almost 10 years. And they really shine on that. I cannot really contrast it with Kafka, but Splunk is just a way to stitch together your, I guess, log files, provide aggregation, timestamping, stitching data, creating workflows. And it's an interesting system, has been around for quite a long time, wide deployment base too. But I cannot really go in comparing. But Kafka, I would say, is more oriented towards acting as that transaction log itself. So Splunk would probably be one of the clients to Kafka. That would be my take on it. Yeah, Paravajit, yeah, no problem. So producers, consumers, exactly what they are, those roles in the world of pub/sub systems. So publishers, both are actually clients to a server, which is called broker. Producer receives an acknowledgement to prevent resubmission of data. Consumer reads the data. The consumer can be grouped in consumer group. I'm going to talk about this shortly. But both act as clients to that log file. So they know how to read it. They need the location. Essentially, they just need to know the IP address and the port of the broker, which actually manages or leads that file. Record, also known as event, message, it's a byte array, can be formatted. Avro is a very popular encoding format. And what's interesting in Kafka is that they use that concept, that notion of an offset, which is essentially an auto-incremented value, which acts as a key when you retrieve a message. So that offset, when the first message comes in, it gets offset 0, then it would be auto-incremented. Next message or event would be indexed as being at position offset 1, and so on and so forth. On top of that, they also have the value for the message, which is a byte array, Avro, JSON, Parquet, and timestamp. Those records are stored on files, and files are actually partitions, and partitions topics, two things that we are going to learn shortly. What you need to know is that records are immutable. There is no update operation. So even though you kind of keep in a state of a particular object, let's say you've got a sensor, right, which is picking up certain signals, and the Internet of Things can be anything. So it gets those streams of the state of a particular object, maybe temperature at your thermostat, or whatever the case might be, your car engine parameter. That value for that signal is not getting updated. A new state is inserted over that period of that time between observations, between reads, and you've got multiple states, and you can play them back. So essentially, when you talk about immutability, it's a way to prevent the system to just wipe out the previous state. Okay, so it's an interesting and very kind of practical way to look at the data. So topic, I guess a topic is what I guess you have in the publish-subscribe system. This is something where the producer produces information for, and the consumers read the data. It's not the whole thing, but this is actually the corner piece, the fundamental piece. It's a commit or transaction log file. And another interesting and important feature is that topics for throughput, for high availability, and for other quality of service are partitioned into partitions. Essentially, partitions are physical files. topic is kind of it's a structure, it's a concept, category, just name, moniker, but every topic is backed up by physical files, which are represented by partitions. And there are some relationship between a topic and consumers. So partition is part of that commit log, and Kafka designers, they just took that I guess clue from HDFS, and they decided to replicate partitions to make them really fault tolerant. Right, so that's the common theme. So make the system highly available by replicating. I guess one way to look at it, if you are familiar with HDFS, Hadoop file system, is that every block is part of a file. File is logical name. So file would be a topic, and that block would be essentially that partition, that 128 or 64 megabytes worth of data. And every block on HDFS is replicated by default in 3 ways. Right? It's configurable value in Kafka. I guess I'm just drawing. I'm not talking about HDFS kind of stored on Kafka. I'm just drawing an analogy so that those people who have experience with Hadoop, they would immediately recognize what I'm talking about. So don't confuse, don't get me wrong. Okay, broker is a centerpiece. Again, it's a service which listens for client requests from producers and consumers. It manages partitions. Even though we don't mention it here, I believe maybe next slide. Just let me go quickly. Yeah, Zookeeper. Because Zookeeper is another thing that you need to be aware of. It replicates messages. It does lots of kind of things, just traffic cop. There is also one broker which is dedicated to act as a controller. It performs some housekeeping tasks. It manages states, partitions. It talks to Zookeeper to do that. And connector is a way to create your integrated solution so that you can kind of organically plant in Kafka and start sort of kind of create producers and consumers around that system. So you've got integration with a variety of systems and pretty much everything that you can have with relational databases. There are JDBC drivers, but what's interesting is that there is also a way to integrate with JMS-based systems, so that you can put a message on a queue which is JMS enabled. Kafka doesn't support JMS out of the box. It's where Confluent is making money by selling you the enterprise edition. It's really worthwhile. S3 cloud storage of Amazon as well. So this is architecture, and you've got cluster, and you've got producers, consumers. Every topic, as you see, is split in 3 partitions. It's configurable value. So when you start, when you create a partition, a topic, you can configure that number. I guess 3 is a good number. You can reduce it to 2. It really creates network noise because every partition needs to be replicated. Replication is also a configurable value. Information about the cluster, topics, offsets, partitions is stored in Apache Zookeeper. Zookeeper is a centerpiece. If Zookeeper is not available, you are out of water. You pretty much have a major blackout for your Kafka service. Kafka depends heavily on Zookeeper for state coordination, for distributed management of resources. Lots of problems come from Zookeeper. That's what I've read about. That's what I heard. At Zookeeper, so people are just looking elsewhere, but in fact, Zookeeper is misconfiguration, not cleaning up the data directory where the transactional log file of Zookeeper is kept. People just don't have good maintenance of the cluster, and over time, everything works fine until, I guess, 3 a.m. On Saturday, right? That's when it happens. Okay, so in terms of efficiencies, Kafka, if you look at on the surface, you don't see much of excitement, right? Okay, so guys just use the file based log file. Very basic system. I can probably do it myself over the weekend, but there are some efficiencies, and those efficiencies are summed up here. Kafka designers, I'm not sure how they, I guess, probably some of the people had very intimate kind of a knowledge of what's insights of what's going in the field of Linux, and Linux is making major advancements in offering services which are really enterprise grade. I'm not sure about Windows. I guess David Cutler from DEC originally, I guess he was thinking about a really enterprise system. Probably they've got similar capabilities. I'm not sure. But kernel of Linux gives you that page cache to socket feature, meaning that you don't have to pay for this. Essentially, you just create a fast track of data transfer between those. And usually you would imagine that when you process data, you've got JVM, your application has so much heap allocated to it, 2 gig, 4 gig, and whatever the case might be. And essentially any I/O operation, whether it's file system faced or networking socket connections, would be pulled out. There would be a change between the kernel, between kernel space and the user space where your JVM runs, and that space transition back and forth. It has associated cost with losing. First, you replicate. There is the cache of the operating system where the data resides. Then you have to copy that cache into heap. You need to apply some operation, and essentially your operation is just around taking that file system buffer and move it to the socket. So there is lots of jitter back and forth between kernel space and user space. Lots of duplication on Java heap of the data which is already available and cached in the page cache for input-output subsystem. And it's inefficient, and I guess those guys, they realized early in the game that that would be probably the most useful feature that I guess Kafka can leverage. I'm pretty sure that other people have started using it as well, and that's what gives them that network near performance. So you essentially produce a message, and that message can be sent out to the consumer by. It's not always possible. In some cases, that operation which is called send file system call, which allows you to take data and transfer it, staying in kernel space. But it gives you efficiencies. It gives you a leg up of traditional systems. Not, I guess. Maybe IIX doesn't support it. Maybe Sunset Ares doesn't support it, but Linux does. Okay, so that's one of those things that probably made all the difference for Kafka. The system call. So the question is, just give me a second, what is state coordination? State coordination is when you've got your partitions. Partitions are replicated. So in order to replicate partitions, you need to know the state of those replicas. There is a concept of in-sync replicas. A system needs to know if everything is homogenized. It has the same consistent view. Also, when consumer takes messages, reads messages from the queue, you need to record the state of that conversation is maintained. Zookeeper keeps a track of offset that the consumer has read the messages. And that offset goes as a state replica goes to Zookeeper. So that's what it is. The APIs, in order to communicate, you've got producer and consumer API with Kafka. And you've got not only Java, that was the original API, now you've got the whole ecosystem of products, clients who can talk to Kafka. Since it's just a file on a file system, any programming language can talk to it. There are Go client, .NET, C#. There is also Streams API, which has been added, and Connector API. So that API allows you to create integrated solutions between Kafka and other systems. Topic is a multi-partition log file. You can have as many partitions as you would like to configure. I guess that's a way to parallelize your processing. You might go overboard, so you have to exercise some restraint as to how many partitions you need to have. There is, I guess, a sweet spot somewhere. Kafka gives you the guarantees of strict record ordering. So record in this case, you see, it's not positioned as an event or message, it's a record. Okay, which is kind of a same thing, named differently. What's interesting is that ordering is supported only within a single partition. So if you've got two partitions on a topic, you essentially cannot enforce record ordering across both partitions. For that, you would need to have an application logic to deal with timestamps. Okay, so that's a pain. Again, there is a trade-off. You have to pay for something. There should be give or take. For efficiencies, producers can aggregate data. It's kind of a batch-oriented processing, and that batch can be capped by a number of messages or by the duration of that batching window. So you've got two parameters, the size and the duration. So that's what a topic with partitions look like. All the images, they do attribution. Most of those images come from Apache Kafka documentation. Good documentation, by the way. Maybe it doesn't disclose very much, but at least it gives you a good overview of what you can see. We learn by just looking at things, not by reading. So we've got three partitions, and writes, essentially the insert writes are done by the producers. From the left, we've got the original state when we just launched the cluster from just clean. And every partition has its own offset. So those 0, 1, 2, 3, 4, 10, 11, 12, those are offsets for messages. And messages are those byte arrays. Partitions are distributed, as I said, and data is written to partition randomly. There is some load balancing and parallelism considerations coming into play. And for you to reconstruct that stream of the original stream of events coming from a particular producer, you need to use timestamps, right? Because that offset is not going to help you. Okay, so you can think about, like, you've got essentially a message queue, and that message queue was just split into, I would say, it was parallelized, and you've got same, not replicas, but configuration-wise, similar capability, which does the same thing, which is can be addressed logically by the same name as a topic, but you create several separate threads of producing and consuming. And for fault tolerance, partitions are replicated and it's configurable value. More on that, how it's done in a second. Consumers subscribe to one or more topics and perform sequential random reads. In order to access that particular record, consumer needs to provide to the broker, which actually keeps track of all those things, the following three pieces: the topic name, the partition ID within that topic, and then the offset of the record within that partition. If you confuse any of those things, you would probably get some garbage. right? You can also get a batch of records, which is a highly optimized operation. Right, so broker handles it, and consumer, because you don't delete messages by default, can go back and reread those messages. It might be useful for some use cases. It supports stateful computation. So there is a question, is there going to be a demo on how Kafka works? No, Louis. Unfortunately not, we don't have time, and I'm already running out of time because we've got more slides to cover. But would this presentation talk about Storm? No, it's exclusively for Apache Kafka. And definitely it's not even enough for just giving a quick overview. Okay, so if you have interest, please talk to your account manager or your HR, your learning specialist, and they would contact WebAge, and we would be happy to provide that overview of Storm. Okay, leader and followers. So it's pretty much kind of a master-slave type of scenario. It's a pattern named such that it really shows the proper role decomposition. So the leader is the primary service, primary broker, which handles all the reads and writes. And followers are slaves, which essentially hold replicas. Those are kind of a hot standby. If the leader goes under, then any of those followers who have a replica of a partition would be elected by Zookeeper to act as the leader, next leader. Okay, so followers passively replicate the data. There might be some inconsistencies if you've got a kind of a shutdown of a system. So you might have, that's what I heard, that you might lose your data in some scenarios. Okay, what else? Generally, that feature is useful because it gives you some resiliency, fault tolerance, but at the same time, it comes with complexity. You need to properly configure, because there is a way to misconfigure your system, and there are lots of horror stories. People start kind of flaming on Kafka, but if you really drill down to what the problem is, it's just misconfiguration. People probably have not thought far enough how to use Kafka in those for those use cases that they envisioned. So that's a picture of leader and follower. So we've got 4 brokers, 4 machines, 4 services, 4 servers, and we've got 3 replicas and we've got 3 partitions. So that's what the system would load balance when the producer would write in a partition, right? There would be 2 replicas of the same, then the second partition would have same replicas. If you're familiar with HDFS, this is something which NameNode does, right? It does this kind of creative load balancing, trying to harmonize the loads, just making a fair share of work for every server, right? Message delivery guarantees. It's important to understand that what Kafka can give you. Ordering is very important, and Kafka enforces it, and everything is done by offset. You also have timestamp on top of that. What's interesting is that when you consume messages from a log file, essentially that offset is not reset to 0. So that's important, meaning that when you reduce that queue length, queue depth for a particular partition to 0, and you start adding new events, records, messages, you would start from the previously maintained value count plus 1. That value is kept in Zookeeper. So Zookeeper, as you see, plays a central role. And if Zookeeper is toast, for Zookeeper you would definitely need not to have the single service as is provided by Kafka. You would need a quorum. You need a cluster of Zookeeper machines, maybe 3, 5 machines. to ensure that they do their applications, they have their own high availability quality of service. And consumer also sees records in order they are stored, so they start reading the way they want, pretty much by specifying the offset. Okay, so batch compression, Kafka goes an extra mile to give you some additional service. They recognize that your data would probably be, you would be better off to use compression. Of course, it would be counterproductive if you start applying compression on very short messages. You would start getting benefit if you've got text files large in size. And those snappy algorithm is a very popular one. Will give you dramatic improvement. First, for read and write operations, because most of the time would be kind of spent, I guess, not reading data but decompressing and compressing. So there is a trade-off. You need to experiment for yourself and see for yourself if your particular use case lends itself to using compression. Consumer groups is a concept that I guess Kafka boasts as something that improves parallel processing of messages. Essentially, you've got a number of consumers who are grouped into that group performing similar type of action, reading data. There are some restrictions or caveats, that fine print that you need to be aware. A single consumer can read from multiple partitions, which is good, but probably not what you expect. But the real constraint is only one consumer from a group can read messages from the same partition. So in this way, one of the, I guess, problem with asynchronous message consumption, not so much producing and storing, but consuming, that different consumers can read messages because of the asynchronous nature of consuming data out of order. Even though messages are properly stored, acknowledged for writing, but when data is fetched from the queue, different consumers can get messages out of order. And for that, systems enforce it by introducing an exclusive consumer who acts as that only consumer who has access, who has the key to that message queue. Right, so that's the pattern that I believe Kafka uses for allocating just one consumer from a group. But you can have another group if you really want to speed up things, and you would need to have artificial group, which would essentially allow you to break that constraint. But there would be probably another level of complexities. So when you start seeing those things, you would probably start having this sense of kind of a little bit of apprehension. So what might happen if I go out of sync? What if happens to that group? Are we going to shut down the whole messaging consumption? A couple of pictures, they're not related. They're related to the same kind of a topic, but they are not related between themselves. So the overall one from documentation of Kafka is confusing. I guess another one, I guess it's Confluent, or maybe Kafka documentation as well, which just shows you how consumer group can consume messages. It's just a cleaner way, the below one. If you understand the one which is below, go up and try to actually visualize how things happen there. Log compaction, it's a very popular, I guess, mechanism to preserve I guess some boundaries. HBase uses it, other systems as well. It's just a way to perform reduction of the log. That compaction is just reducing the log file. And it has its own semantics. You can liken it to SQL update operation. Essentially, previously stored data, previously stored records are updated, and you've got a new view of your data. And the old data is gone. The state is gone. So you have smaller log files, you have finer control. Message ordering is preserved, and there is a nice slide which actually shows what happens. So let me just highlight you a couple of things. Okay, whoever wants to leave, thank you for attending. Thank you for your words. Okay, we're almost done. We've got 10 minutes before. We need to shut it down, but let's move on. I guess we are almost done. Yes. So what's happening here? I guess let me quickly highlight a couple of things. So we've got, as you see, we've got every record, every message is characterized by 3 properties, right? It has a value, which is a byte array. We've got a key, right? And that key might be timestamp, can be a specific value that you set, or offset. So those offsets go from left to right, auto-incremented value. And what's happening? Let's say we've got key 1, right? We've got first record, second, and third, right? The most recent one contains value 4. So when log compaction happens, it's on-demand operation. This is log before compaction, and that's what would be the view of the log after the compaction operation has completed successfully. So we've got all those previously stored values essentially removed, and the recent value for a K1 would be preserved. And same applies for all those keys. Essentially, you've got a dramatic decrease in size, but you have lost all the state. I guess when you do this, you need to think really multiple times and run it by maybe business. Maybe you can just take a snapshot of that log file and perform compaction. So it's a file-based system, not proprietary. Nothing really prevents you from applying some of the traditional backup operations to copy it over. It might be locked, but I guess you can probably take your system offline, take a copy, and whatever, I guess, operational policies you have in place. Kafka Editions. Kafka Editions, this is information, that's a page from the Confluent website. It gives you side-by-side comparison between various options that you can have. Kafka gives you enough Apache Kafka from the Apache website. Good way to start, but I guess Confluent really wants you to keep on their website. They offer you some additional features, such as a bunch of connectors, as we mentioned, REST proxy, so that you can access and your system using HTTPS. Enterprise and Confluent Cloud give you the really scope for a number of services and use cases that you would be interested. So JMS client probably comes to mind first, right? Auto data balancer. So whenever you see those things which are only available on an enterprise edition or cloud, think about that this feature is badly needed in open source and Apache Kafka. So probably you would have a problem with load balancing. So you need to kind of think about those situations where you would really need that urgently, right? So that would be the way to read it. So what you need, and probably maybe you need just support. 24/7, maybe like not only the first level, but really third level support, access to those developers, and maybe you would point out to a bug which currently exists. They really stabilizing the system. They always, I guess, welcome that feedback. Okay, so that's it. That's what I wanted to, I guess, talk about Apache Kafka. Any questions? We've got a couple of minutes. Okay, I see people leaving. No questions. Going once, going twice. Okay, guys, thank you very much for attending. WebAge is currently working on providing a 2-day class on Apache Kafka, so it might be an interesting topic for us to produce and I guess for you to consume. Okay, all the best. Bye-bye.